Okay, so how did she say the rule from Pascal's triangle related to these shapes?
Well, you can sort of add the two shapes above a number to get the shape for that number. So like, you can sort of think of adding a point and a line together to get a triangle.
Okay, so let's start it with the one above, adding these 2 points to produce this line segment. How did she do that?
You have these two points, and then you just add them. You get the point and 2 points at the end of the line segment.
Okay.
And then you fill in the space between them.
Yeah. So let's go talk about the procedure carefully. What did you do with these 2 points?
So we put one of these points at the start of a line segment, and then we put one of them at the end.
Okay.
And then we filled in the space between them.
Okay.
And that created a line segment.
All right. Cool. So what I think she said is you kind of put them on top of each other and then sort of fill in.
Yeah.
All right. And notice in the 0, 1, 2-dimensional case, the middle part was 1 dimension. Okay? Because we were slicing through with a plane that was 1 dimension less. So the intersection of the n-dimensional object and the n-1 dimensional object was going to be n-1 dimensional.
Yeah.
Okay? Although at the end points you just hit one single point, so that doesn't work there. But let's talk about how you add the point and the line segment to make a triangle. How does that work?
So since you're working in two-dimensional space, you've got two planes that are parallel to each other. And then you put the point on one of the planes.
Uh-huh.
And then you put the line segment on the other plane.
Okay.
And then connect them up and fill in the two-dimensional shape that results.
This is the convex hull.
Yeah, she called that the convex hull. Okay. So there's the point and the line segment, and that's this point, the line segment and a point too.
Yeah.
Okay, now we can think about it actually, and this will be somewhat important. The first one is a point, remember we're putting them on top of each other, so a point and the line segment, and then you fill them in.
Yep.
But this one's a line segment and a point, so technically this one, if we follow her directions perfectly,
It's upside down.
is upside down. And it was it up? Were these two triangles facing the same way? In the
No.
They were one of them. They were different directions.
they were actually different directions. So let's make them be in different directions here. So they're the same equilateral triangle. One's just upside down. Okay.
Yep.
So these are the rules for how things work. So we're going to have, for when a three-dimensional plane hits a four-dimensional cube, we're going to have something that goes 1, 4, 6, 4, 1, and it's going to be point, 4 vertices, 6 vertices, 4 vertices, then the point.
Well, that would mean we have to take a point on one of the vertices and one of the planes,
Uh-huh.
and we have to take a triangle on the other, and then fill in the space.
Okay. And so do you think that's going to be a square? Don't say what you think it's going to be, but do you think it's going to be a square?
No.
No,
Why?
because there aren't equal points on each. There's 3 is unbalanced. There's 3 on one side and 1 on the other.
Okay.
And also, you already have a triangle,
All right.
and you don't change the shapes. You just put them together.
Okay.
So we probably won't get a square for 4.
Okay, but there's another very important reason why we won't get a square.
Well, you've got 3 points that are going to be on one three-dimensional plane,
Uh-huh.
and 1 point that's going to be on the other three-dimensional plane.
Okay.
But the 3 points that are already connected up,
All right.
so you can't make a square. It's an equilateral triangle. You have the wrong angles.
Yeah, that's all right, but there's one other really important thing. This middle one is one-dimensional here. In the two-dimensional square, we get a one-dimensional thing in the middle.
Yeah.
In the three-dimensional square, what's the dimension of the things in the
2.
middle?
2.
In the four-dimensional,
It's going to be 3-dimensional.
right, so the reason we know it's not going to be a square is because it's going to be three-dimensional. you're right in that the points won't line up the right way anyway to make it a square, but it's going to be a three-dimensional shape. Okay?
Alright.
All right, let's go on and see if we can figure out what shapes they are.